Hey everyone, today we are going to identify the IUPAC names of these compounds, these random compounds here. If you want to identify the IUPAC names of these compounds, first we needed to know what kind of compound is that. Okay, for that we have to take a look into the functional groups present in the molecule. Say for example, when you have an OH functional group, we can conveniently call that compound as alcohol, but do not get confused with the OH that is present in carboxylic acid. Although you know that you have an OH here, but it is adjacent to a carbonyl functional group, and therefore this is called as carboxylic acid. Okay, let's go ahead and get started with our first example. In our first example, we have got a total of 6 carbons in the cyclic structure. Okay, let's count the carbons. 1, 2, 3, 4, 5, 6. So if it has got 6 carbons, we know that it's going to be cyclohexane. That would be the parent name of this molecule. Once we have identified the parent name, we are going to find the substituents. What are the two substituents we have in this molecule? We have a methyl group, right? In most of the skeletal structure, we usually do not put the CH3. Whether we have the CH3 or not, it is understood there is definitely a methyl group here. Okay, so this one right here is a methyl group. And this group right here, this substituent right here is called as a vinyl substituent or a vinyl group. This is something for you to memorize. Okay, anytime you have a carbon-carbon double bond, it can be conveniently called as a vinyl group. Okay, now we have identified the substituents, and the next thing we are going to do is we are going to give the position of these two groups on the cyclohexane molecule. Okay. So one of the rules in the nomenclature is we need to make sure that these substituents get the lowest possible number. So we have to assign this to be carbon number 1. And of course, you can also try to give the numbers for all the rest of the carbons, but here there is no use for it because we do not have any other substituents present on other positions, right? Now let's complete the IUPAC name for this compound. So we have a methyl group and we also have a vinyl group. But where are these two substituents located? They are located on carbon number 1. So once you have this, you need to make sure that you arrange them in alphabetical order. Which one comes first? Between M and V, obviously M comes first, right? So let's complete the name for this molecule. 1-methyl, right? And 1-vinyl cyclohexane would be the name for this molecule. Remember, I have arranged them in alphabetical order, and also need to make sure that their number and the alphabet will be separated by an hyphen. Okay, and there should not be any space between an L and C. Let's go on to the next example. On the next example, we have got a functional group. This is going to be our functional group. But what is this functional group? Let's identify. For that, we are going to expand the structure. Let's expand the structure here. So we have already a methyl group. This carbon is doubly bonded to oxygen and singly bonded to hydrogen. So only in that way, this carbon is going to have 4 bonds, right? So doubly bonded to oxygen and singly bonded to hydrogen. And this group right here is called as an aldehyde functional group. Now let's take a look into the chart to verify our functional group. Here we have an aldehyde. So this is the carbonyl functional group. We generally call this as carbonyl. This is a carbonyl functional group. And when you have 2 R's on the carbonyl functional group, we generally call this as ketone. When you say R, it's basically a methyl group or ethyl group, or it could be any alkyl group, right? So it's going to be connected to carbon. But in the aldehyde, you will be having 1 carbon, okay, and 1 hydrogen. Or it could be both hydrogens. Okay, so this is definitely an aldehyde, right? Why? Because it's connected to 1 hydrogen and 1 carbon. At least 1 hydrogen should be there for an aldehyde. You can have both hydrogens. Both of these, instead of having carbon, you can also have hydrogen. Okay, so we have confirmed that this is an aldehyde functional group. Now, once we decide that this is going to be an aldehyde functional group, we are going to identify the parent name for this molecule. The parent name for this molecule will be carbaldehyde. When you have an aldehyde functional group that is directly attached to the ring structure, then it's called as carbaldehyde. So this one right here is a methyl group, and this one right here is a carbaldehyde, right? And this one right here is a cyclohexane structure. We're going to put all of these together. Okay. So the parent name would be cyclohexane carbaldehyde. But where this carbaldehyde is present, it's present on the first position because we need to make sure that you give the lowest possible number for all the substituents. So this would be carbon number 1, right? And both the substituent methyl group and as well as the carbaldehyde is present on carbon 1. So 1 carbaldehyde, and before the cyclohexane we need to also put the 1 methyl. So the right name for this molecule is 1-methyl cyclohexane 1-carbaldehyde. Let's go on to the next compound. The next compound has got an hydroxy group. Whenever you have an hydroxy group, the parent name should end with all, right? So here again we have a cyclohexane ring structure. So cyclohexane, and you also have an hydroxy group. The hydroxy group should be said as all. But where is this all present? Where is this hydroxy group present? It's present on the first carbon. When you have two substituents and both the substituents are present at one carbon, then obviously that carbon needs to be 1. So therefore this would be cyclohexane 1 all. Technically it should be cyclohexane 1 all because you have two vowels. Say for example you have cyclohexane 1 all. Because you do have two vowels connecting it, you will be reducing that to one vowel, so you will definitely avoid this E. Okay, so it should be called a cyclohexane 1 all, but we also need to give the position for this. We also needed to specify this methyl group. This methyl group is at the first position also, right? And therefore this should be 1-methyl cyclohexane 1 all. That would be the correct name for this molecule. Let's take one more example of the alcohol. We'll compare this structure with this. Here also we do have an hydroxy group, but this hydroxy group is not directly attached to any of the ring carbons. It's not attached to any of these carbons. Instead, it is attached to this carbon. So in that case, we have to consider this as the parent name. Now, how many carbons do we have where the hydroxy group is attached? Only one carbon. Whenever you have one carbon where the hydroxy group is attached, then it's going to be called as methanol, right? So it's going to be called as methanol since this is the structure for methanol, and you can consider replacing one of these hydrogens with this group right here. You're going to replace the hydrogen with this group. So we have changed that. So probably I'll highlight this. So this group has been replaced for this entire group here in the structure. So instead of hydrogen, we just have this group. Okay, now how are we going to name this compound? So the parent name would be methanol. Let's write it down. But on methanol is present this group. This group right here is a cyclohexane, and on cyclohexane is present a methyl group. And you have to assume this is at position 1 of the cyclohexane ring structure. So it would be 1-methyl cyclohexyl methanol. But remember, you have to put this in parentheses. If you're not going to put it in parentheses, this has got a different meaning for it. Only if you're going to put the parentheses, it means that this entire group is present on this carbon. Let's do one more example. Here is one more alcohol. You can also draw the actual structure of this compound. So these carbons right here, terminal carbons, are going to have CH3, are going to be CH3, and these carbons where you can see two bonds coming off of it will have two hydrogens, right? So here you will have two hydrogens. So we said these carbons are going to have 3 hydrogens, right? Okay, and this carbon, since you see 3 bonds, there should be 1 hydrogen here hidden. So this should have an hydrogen. And this carbon, you already see 4 bonds, right? So there should not be any hydrogens on it. Okay, so the actual structure of this compound will be like this. Here in this case, you're going to find out the longest chain in the molecule. So you're going to find the longest chain. Let's find the longest chain. You go in this direction, let's see, 1, 2, 3, 4, 5, 6 carbons, right? So if it's going to be 6 carbons, then it should be definitely hexane, right? Hexane. But since it has got an all hydroxy group, I'm not going to complete it with an E. Instead, I'm just going to leave it like that. Okay. Now we need to give the hydroxy group the lowest possible number. So this hydroxy group needs to get the lowest possible number. Now if you go in this direction, let's say that you're going to number in this direction. 1, 2, 3, 4. That puts the hydroxy group at position 4. But if you number in the other direction, let's say that you're going to number in this direction. 1, 2, 3. That puts the hydroxy group with the lowest possible number, 3, right? So obviously you have to go from right to left for this molecule to name this. So the hydroxy group is now present on the third carbon. So let's complete this. So this would be hexane 3 all. This would be the parent name for this molecule. So when I said hexane 3 all, we just gave the name for this highlighted part. So we only gave the name for this highlighted part. Okay, we are still left with this methyl group, these two methyl groups right here. But where are these two methyl groups present? One is present on the third position and the other one is present on the fourth position, right? So we needed to put 3, 4. Since there are two methyl groups, right? Two methyl groups, we have to put a di in the front. Okay, we should add the prefix di. So 3, 4 dimethyl hexane hyphen 3 hyphen all. Make sure whenever you have a number, this is the most important thing. Whenever you have a number and an alphabet, they should be separated by an hyphen. Okay, so this should be the proper name for this molecule. Let's do this example right here. Here we do have a carbonyl functional group, and this carbonyl functional group has got carbon on each side, right? So if you want, you can also convert this into a like an actual structure. Each of these carbons right here is going to be CH3 because these are terminal carbons. And this carbon, since you can see 2 bonds, there are 2 hydrogens hidden, right? So that would be CH2. And this would be another carbon, which would be doubly bonded to oxygen. And this carbon would be connected to 3 hydrogens. So that would be CH3. Now you can see that this carbonyl functional group is connected to 2 carbons, 1 on each side. And therefore this will be a ketone. If you want, you can also take a look into the functional group. So here is the difference between aldehyde and ketone, where you can see that the aldehyde should have at least 1 hydrogen, but it can also have 2 hydrogens. But a ketone should have 2 carbons, right? So this is a ketone. Now how are we going to name this? How many carbons do we have? 1, 2, 3, 4, right? There are 4 carbons. Therefore, it's going to be butanone. Remember, ketone should end with -one. Butanone. But since you have the keto group in the second carbon, remember, you need to make sure that this functional group gets the lowest possible number. So you have to go number in this direction. 1, 2, 3, 4. Instead of numbering in from left to right, you have to make sure that this carbonyl group gets the lowest possible number. So this should be 2-butanone. Okay. So, or you can also write this as butan 2-one. That would also be proper name for this compound. Next, we'll do the IUPAC name for this compound. This is an example for an alkyl halide. Here again, we do have a cyclohexane ring structure, and both of these substituents, bromine and as well as methyl group, is present on carbon number 1 on the same carbon, right? So we have to assign this to be carbon number 1, and the parent name would be cyclohexane, and on cyclohexane is present bromo group and as well as a methyl group, right? And you have to list these two substituents in alphabetical order, right? So it would be bromo first. So make sure whenever you list the substituents, you also need to give the numbering for it. 1 bromo. And make sure you put the hyphen because we are going to put the number in 1 methyl cyclohexane. That would be the name for this molecule. Similar to how we have named here. Okay. So B comes first and then comes M. Let's take a look into this molecule. This molecule is not completely an organic compound. Instead, it's called as an organometallic compound. This is an example for organometallic compound because you do have a metal. You do have the metal magnesium. Whenever you have MgBr or MgCl, it's called as Grignard reagent. Grignard reagent. Okay, now let's see how we are going to identify the name for this molecule. Again, this part right here is cyclohexane, right? And you have a methyl group. So it will be methyl cyclohexyl. And this is magnesium bromide. Magnesium bromide. And this is a methyl group. So since it is a Grignard reagent, since it is an organometallic compound, this would be called as magnesium bromide. The parent name would be magnesium bromide. And we are going to put this entire stuff, entire substituent in the front. This would be called as 1-methyl cyclohexyl. So similar to what we have learned here, this would be this group right here is 1-methyl cyclohexyl, right? So we are going to put the whole thing within the parenthesis. Let's go on to our last example here. What do you think is this? Yes, it is an example for Grignard reagent, or it's an example for an organometallic compound because we do have a metal, right? We again have magnesium metal. So this compound should also be called as magnesium chloride. That would be the parent name for this. And let's find out what is the other thing that is sticking off from it. So this part right here, generally called as secondary butyl. Why? Because this carbon is a secondary carbon. This carbon is attached to one hydrogen. Right? Whenever you have a carbon that is attached to one hydrogen, it's called as a secondary carbon. So this is a secondary carbon. And let's find the number of carbons here. 1, 2, 3, 4. So therefore, this whole thing will be called as secondary butyl. Be secondary butyl magnesium chloride. Or you can also name this in a different way where you're going to call this one as 1-methyl propyl. I'll write it down first and then we can go over this. 1-methyl propyl, this whole thing is going to come in parenthesis followed by magnesium chloride. Okay. Now how this is going to be 1-methyl propyl? Okay. So you focus on this carbon. You're going to find which one has got the longest chain. You can go in this direction or you can go in this direction. So which one has got the longest chain? Obviously, going towards the left has got the longest chain. The longest chain has got a total of 3 carbons, and therefore you're going to put as propyl. Okay, and you have to give the numbering here 1, 2, 3. Remember, you need to make sure that you give this carbon as number 1 because you are going to consider this as a functional group, and therefore this should be the one which gets the lowest possible number, right? And then you do have a methyl group here. And this methyl group is attached to the first carbon. So therefore, you are going to put that as 1-methyl propyl magnesium chloride. That would be the complete name for this molecule. You can choose to write it like this or like this. Both of them should be right.